For the very first moment in the history of humankind, there is a real possibility that humans may one day walk on the surface of Mars. And you can owe Elon Musk's relentless pursuit of his dreams to this success. The millionaire is constructing the formidable spaceship known as the Starship, and it will be used to transport participants to the considerable distance that separates Earth and Mars. However, given that the voyage into deep space would take many months, Elon Musk's business, SpaceX, will need to devise a strategy to shield the passengers from the adverse effects of microgravity for the whole length of the trip. This is the motivation for SpaceX's creation of a Starship with artificial gravity. What kind of spaceship is this, and exactly how does it go across space? Welcome, and you are watching Technology Zone, where the home of technology resides. Come along with us as we investigate SpaceX's ridiculous artificial gravity Starship. Musk is moving on with his plans to transfer people from Earth to Mars in order for them to live there permanently. This is the case regardless of whether you believe that getting to Mars is a foolish endeavor or that it is not going to be successful. This is the primary reason he is working on the construction of the Starship, the space rocket that has the potential to be the most powerful ever constructed. It will have the capability to transport either people or freight, depending on how it is organized. The Starship is one of a kind in many distinct matters. It has the ability to take more than 100 tons into orbit, which is essential considering the fact that many tons of supplies need to be sent in advance by the settlers. This will include the mechanisms that are necessary to keep them alive. Keep in mind that Mars is a very hostile environment, and because of this, specific preparations will need to be made. Musk is responsible for providing everything from food and water to the resources needed to build shelters and the gear required to produce rocket fuel. The Starship that SpaceX is developing will include an upper stage in addition to a lower stage. The lower level, or the Super Heavy booster, will come back to Earth at the time of separation, while the ship will go on to Mars after refueling in orbit. Both phases of the Starship are totally reusable, which helps keep the overall cost down. After landing, the rocket undergoes a quick inspection, and it is immediately prepared for the subsequent flight. For its propulsion, it will rely on around 30 Raptor engines. SpaceX is responsible for the design and development of the Raptor engines. The upper stage would also re-enter the Earth's atmosphere after each mission, and it will be protected by tiles that are resistant to heat to prevent any damage from occurring as a result of the heat created. About 1,000 of these Starships are going to be manufactured by SpaceX, and the company intends to launch at least 3 of them every single day. Musk will be able to attain his objective of 1 million people living on Mars much more rapidly as a result of this. Obviously, the Starship was not designed to make journeys to Mars on its own. In the next trip that SpaceX sends to the Moon, they want to employ the Starship. After the astronauts have finished their tasks on the Moon, the spaceship that brought them there will pick them up and take them back into orbit. The Starship is a rather straightforward vessel in terms of its function as a freight transporter. On the other hand, when the Starship is supposed to carry humans, there are going to be some challenges. Due to the fact that this will take many days, SpaceX will not be concerned about it on shorter journeys such as those to the Moon. However, the journey from Earth to Mars takes many months, and during that time, the passengers aboard the Starship are subjected to dangerous levels of radiation as they traverse Mars' hostile climate. The installation of barriers on the Starship is an obvious solution to this specific issue, which may be easily resolved. However, gravity is another issue that does not lend itself to an easy solution because they are required to adhere to a demanding workout program while they are stationed on the International Space Station, and astronauts who are not traveling as far as this problem negatively impacts Mars. Even yet, this is not always sufficient since astronauts who have just returned from months-long missions often need to be stretchered out from their ship when they arrive back on Earth. You may have seen movies that feature a storyline centered on traveling across space. Mostly, you will observe a spaceship inside which the characters either dwell or even battle and fight one another. Nevertheless, in most cases, the screenplay says nothing about the spaceship's gravity. Regardless of what the dispute is about, those travelers who make it to their destinations alive are able to disembark and continue on their route. Musk probably wishes he had such a luxury, but the reality outside of films is not nearly as sympathetic as it is shown to be. On board the Starship, he is going to have to manufacture some gravity. According to Nitsa Sintron, chief of NASA's Space Medicine and Healthcare Systems Office, the following are some of the effects that microgravity has on the human body. Understanding these effects will help you fully grasp the magnitude of the problem that SpaceX needs to solve in regard to microgravity. Because bone is lost at a rate of 1 to 1.5% per month in microgravity, this leads to an escalation of age-related changes akin to osteoporosis. Some areas of the skeleton, such as the pelvis, have more significant bone strength and density reductions than others, despite the fact that most of the loss may be reversed once the astronaut is back on Earth. Long-term exposure to weightlessness is related to an increased risk of bone fractures and kidney stones, both of which are caused by bone demineralization. Weightlessness also raises the risk of osteoporosis. In addition, research reveals that the capacity of bones to recover after being fractured is altered by exposure to microgravity. Muscles are also negatively affected by extended stays in space. Loss of muscular mass, endurance, and strength, particularly in the lower limbs, are all symptoms of this condition. Astronauts are susceptible to tiredness and injury due to changes in muscle function, the impact of microgravity on connective tissues, and the demands of activities of varying intensities. The human neurovestibular system is an integrated network of neural sensory, motor, and brain circuits that helps people maintain balance, create a stable vision, and interpret body orientation in terms of direction and position. Microgravity has an effect on this system. After returning from a lengthy flight, those who have been exposed to microgravity often experience confusion, as well as a loss in their neuromuscular coordination. In the moments shortly after landing, astronauts can have trouble rising, keeping their eyes steady, walking, or moving. Exercise is an excellent method for reducing significant muscle atrophy during extended voyages, and astronauts utilize the cycle ergometer and treadmills with downward force pressure to retain their fitness throughout these journeys. The astronaut Scott Kelly can vouch for the truth of these statements. According to the information provided in his book Endurance, he found it difficult to grow accustomed to life on Earth after serving 1 year in space as he participated in NASA's twin study. In order for Musk to achieve his goal of establishing a self-sufficient civilization on Mars, he must guarantee that the passengers he sends there are in their best possible condition. If he does not succeed, then all of them will be killed, and his plot will fail miserably. But before we continue, would you want to participate in Musk's dream of colonizing Mars? Comment down your feedback below and let's see if we get many willing participants. It is interesting to note that while SpaceX is the first firm to have to deal with the devastating impact of microgravity in absolute rocket manufacturing, it is not the only company to seek to find a solution to the issue. One of the first instances of a solution that worked in microgravity was an idea that Konstantin Tsiolkovsky developed. Tsiolkovsky is recognized as being among the pioneers in the fields of rocket technology and aerospace engineering. 1903 was the year that he presented a report under the title Investigation of Outer Space Rocket Devices, in which he proposed the use of rotating force as a means of producing artificial gravity in space. Since that time, other iterations of this concept have been suggested for use in the construction of space stations and habitats. These iterations include the von Braun wheel, the Stanford torus, and the O'Neill cylinder. Some designs are even being investigated for construction, such as NASA's Nautilus X space station, which would employ a spinning torus to produce artificial gravity, or the proposal for a commercial space station that the Gateway Foundation has put up. Unfortunately, each of these approaches has limitations that render them either impractical or incapable of functioning with the Starship that Musk is currently developing. Some of them feature really odd forms, which will make it challenging to get them off the ground. Some are impractical because they are excessively cumbersome, while others can't be used because they use an excessive amount of fuel. Small stars on YouTube have a great idea that will be compatible with SpaceX's flagship spaceship and operate very well with it. It employs a method in which 3 starships travel in tandem with one another. The transport system comprises a cargo Starship and 2 passenger Starships that are positioned on each side of the payload Starship. The payload compartment is stuffed with a truss that can automatically unfold and deploy itself, which allows it to function as the spokes of the wheel. Each Starship will leave the Earth on its own individual rocket, but once they are connected, the passenger ships will rotate to realign themselves and ignite their thrusters to transfer momentum to the wheel. After a sufficient amount of velocity had been generated to stimulate Earth's normal gravity, which is equal to 9.8 meters per second squared or 1 g, the passenger ships would realign themselves to face inwards to the hub ship or the central payload Starship. This would take place as soon as enough velocity had been accumulated. Because of the centripetal force that was generated by the wheel rotation, the remaining portion of the voyage would consist of the passengers boarding the passenger ships, having the impression of being pushed downward. As Small Stars outlines the idea, the components include the gravity-linked Starship concept eliminates the need for impractical space building and spacewalks while also providing a spin gravity that reuses the main engines, taps into spare fuel, and offers an alternative source of power. The GLS functions primarily as a hub ship, analogous to the center of a wheel. The payload bay of the GLS is not used for transporting people or luggage. Rather, it is equipped with a truss that can mechanically fold out and lock into position in order to serve as the spokes of the wheel. What kind of velocity would SpaceX have to reach for the Starship to imitate the gravity of the Earth accurately? Small Stars came to a conclusion after using a spin calculator that the system must achieve a rotational velocity of 31 meters per second if the unit is roughly 100 meters long in radius. This is the minimum requirement. This will result in a sensation equivalent to 1 gram and make 3 revolutions every minute. Small Stars also determined that this approach would need the least amount of fuel in order to initiate and halt the spinning, as well as to get the Starship ready for landing. Even though the passengers will have to continue to adhere to their rigorous workout regimens, there is a higher possibility that they will land on Mars in excellent health. Please leave your thoughts in the comment area below on how you believe SpaceX will be able to create gravity aboard the Starship while it is traveling to Mars.